Now let's see strain components in 3D. So we will see normal strains, shear strains, rotations, and volumetric strain. Let's say U is displacement in x direction, V is displacement in y direction, and W is displacement in z direction. So with that, the normal strains we have already derived in earlier lecture. So epsilon 11, epsilon 22, and epsilon 33 are normal strains in x, y, and z axis respectively. The epsilon 11 is dou u by dou x, epsilon 22 is dou v by dou y, epsilon 33 is dou w by dou z. Okay. Then shear strains, and we have seen this and derived. Gamma 12 is a shear strain in 1, 2 or xy plane, that is change in angle between 1 and 2 axis, or change in angle between line segments of x and y axis, and it is given by dou v by dou x plus dou u by dou y in differential form. So if you see this first term, dou v by dou x is displacement in, or I would say the first term is y displacement in x axis, and the second term dou u by dou y is x displacement in y axis. So it represents the change in angle or distortion, right? Similarly, gamma 1 2 3 shear strain in 2 3 plane, or yz plane, is equal to z displacement in y axis plus y displacement in z axis. Similarly, shear strain in 1 3 plane is equal to z displacement in x axis plus x displacement in z axis. Then we have seen rigid rotations. Okay. Omega 1 2 is equal to dou v by dou x minus dou u by dou y. If you see shear strain and rigid rotation components, they are very similar. Okay, only this the sign, there is a change, there is a sign difference here in the second term. Okay, and this is divided by 1 2. Then volumetric strain. Okay, so basically we know there are basically three types of deformation modes. One is stretching, okay, or compression. Okay, this is related to normal strains, right, or axial strains. Then shear or sliding kind of deformation mode, okay, which is related to shear strain, shear or sliding. So stretching is normal strain, this is shear strain, and there is another deformation mode, that is volumetric compression or volumetric expansion. So we can say volumetric change. Okay, and the measure for this volumetric change is volumetric strain. Volumetric strain epsilon v is given by normal strain, all the summation of all three normal strain components, epsilon 11 plus epsilon 22 plus epsilon 33. Okay. And if you see dou u by dou x plus dou v by dou y plus dou w by dou z, here there are no shear strain components, because we know shear strains do not contribute in volumetric change. So that's volumetric strain. Okay. So this is about strain components, and we have written we have 9 stress components in stress matrix. Similarly, we have 9 strain components in strain matrix. So 3 normal strain components and 6 shear strain components. Okay, we can say here gamma 1 2 is equal to gamma 21. Okay. Or in general, I can write gamma ij is equal to gamma ji. Okay. So three normal strain components and six shear strain components. And rigid body rotations, similarly, no, there are six rigid body rotations components: omega 1 2, omega 2 3, and omega 1 3. And similarly, omega 2 1, omega 3 2, and omega 3 1. So here we can say omega 1 2, or I will write it in ij. Okay? So omega ij is equal to minus omega ji, because this is rotation. Okay, as we know, the rotation we have seen here when we look from this side. Okay, positive normal axis. Okay, when we look from this side, and if it is anti-clockwise, it is a positive rotation. So this is omega 1 2. So similarly, omega 2 1 means we have to look from this side, and when we look or view from this side, anti-clockwise will become clockwise, and that is the reason omega 1 2 is equal to minus omega 2 1, or in general minus omega ij is equal to minus omega ji. So there are six rigid rotation components and volumetric strain. Okay, and one thing I missed in last lecture about shear strains. Shear strain, this is positive shear strain. So positive shear strain results in no, reduction or decrease in angle, whereas negative shear strain results in increase in angle. Okay. So I can draw it here. This is undeformed shape. Okay. So this is decrease in angle. Okay, decrease in angle between two perpendicular line segments, though that is x and y axis. So that is change in angle. So positive shear strain results in reduction or decrease in angle, whereas if shear strain is something like this, okay, or increase in angle, this is negative shear strain. And this is very helpful when you do a post processing of FEA research. Okay, it will help you to understand how the shape change in shape, you know, how it looks and whether it's positive and or negative.